Respiratory distress syndrome affects approximately 10% of infants in the US and nearly 100% of those born prior to 32 weeks. All of these children require respiratory support equipment. RDS results from incomplete lung formation during infant development, usually due to premature birth. The alveolar sacs lack surfactant, the compound that props the air sacs open. Machines like bubble CPAP or BCPAP provide constant positive back pressure to prop the neonate's lungs open. Many NICUs have the ability to support life as early as 22 weeks gestational age, which is not even the end of the second trimester. However, neonates can then be reliant on respiratory support for up to 10 weeks. This is the Fisher and Paykel system that is most widely used in NICUs. It consists of a bubble chamber, a humidifying circuit, and the flexi-trunk interface. This interface is what directly applies the positive back pressure to the neonate. However, it has several disadvantages. The silicone prongs that enter the nares often fit poorly. The smaller sizes are typically too long for smaller babies and cause damage to the insides of their nostrils. The prongs also have a set width, whereas nasal septum's widths can vary heavily. On infants with wider septums, these prongs dig into the septum wall, and worst of all, these prongs apply heavy pressure to the base of the septum, causing abrasions and in severe occasions, septal erosion. We are Team Saving Little Noses, and we were tasked with developing a new interface that mitigates the risk of septal abrasion and erosion. Working alongside with the Golisano NICU team, we have developed a novel prototype for a new apparatus. Our design features a suspended approach that pulls pressure away from the neonate's face. It is equipped with a flexible wire that allows nurses to bend and adjust the apparatus minorly to account for varying nasal geometries. The ends of each tube are also equipped with a pillow prong that flexes to absorb any impact from the neonate's movement or from the apparatus. This apparatus invests slightly more time in the setup for each neonate, but saves significant time by reducing the number of changes nurses have to perform. We followed with testing to prove that our design did in fact reduce pressure. A new testing method had to be developed, as measuring pressure between two soft objects is very difficult. We developed a PDMS puck synthesized to mimic the Young's modulus of neonatal nasal skin. We then measured the deformation of this puck and used the distance to calculate the maximum pressure applied. As you can see, our device in green shows significantly less contact pressure at the nares than the original Fisher and Paykel system in blue. Our team and our customer were thrilled with these results. Subsequent testing was performed to verify other aspects of the design, but this proved that we accomplished our main goal. Through our simulated contact pressure testing, we have proven reduced risk of injury and subsequently a reduced rate of clinical interventions, improving patient and family NICU experiences. Ledernosen has proven potential to achieving our defining goal, saving little noses.